Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are happy with the content in this video, please press like, share and subscribe. Press the bell icon to get the notifications. If you are first time viewing this video, then I will suggest you to go through my introduction video first to understand the presentation structure of the course content. Today we are at detailed explanation class 2 for mathematical induction. Before this class, we had completed the basics of mathematical induction. After that, we had done detailed explanation class 1. Okay. So what we had done? We had distributed the sum among these 11 categories. Okay. And in detailed explanation class 1, we had completed first 4 categories. Okay. In this detailed explanation class, which is class 2, we are focusing on category 5 to category 8. Okay? Category 5 to category 8. Rest 3 categories will be addressed in class 3, which will be our detailed explanation class 3. Okay? Okay. So what we are going to do in this class, I will reiterate. We will concentrate on these 4 categories. Okay, category 5, category 6, category 7 and category 8. So what is category 5? Category 5 is a to the power n where a is constant. Okay, a problem which is having a to the power of n type, like 2 to the power of n minus 3 to the power of n. Such type of problems. Okay, where 2 and 3 are constant and n is at the power. Okay, so such type of problems. Next, n number of digits, like 1 plus 11 plus 111 plus 1111, like that. So number of digits are increasing from term by term, so it will continue to till n terms. Such type of problems are addressed in category 6. And in factorial, we will discuss what is factorial in this category. Okay, if you want a detailed solution or detailed explanation, then you go to my permutation and combination class to understand what is factorial. Okay. Now, in category 8, n in trigonometric function. So, n is involved in the trigonometric function. Such type of problems are addressed in category 8. Okay. So, this is what the overview of this class. We will be discussing these 4 categories. Right? Now, I will rub this out and after that we will look on each problem in each category. Okay? So my problem is 41 to the power n minus 14 to the power n is multiple of 27. Okay, this type of problem can also lie in the divisibility type of problem also, because we are using multiple of 27. Okay, so my mathematical statement Pn, my mathematical statement is represented by Pn. So Pn is 41 to the power n minus 14 to the power n is equal to 27k. Whenever a multiple is written, then it can be written as 27k. Okay, if you want to go through the detailed explanation of multiple or divisibility type of problem, then you can go back to our category 4 and look into the detailed explanation class 1. Okay, so it is 41 to the power of n minus 14 to the power of n is equal to 27k. This is what we have to prove now. So my principle of mathematical induction is a 3-step procedure. Okay, so my first step will be the check step, where I will write my p of 1. Let's see for p of 1 whether it is true or not. So p of 1 will be my LHS 41 to the power 1 minus 14 to the power 1. We will substitute n with 1. Okay, this will be 41 minus 14. Okay, so this will be 27, which can also be written as 27 into 1. So this is the multiple of 27. Okay, this is the multiple of 27. It can be represented in the form of 27k, where k is 1 in this case, right? Okay, so this will be my RHS. Let me write it clearly that what will be my LHS and what will be my RHS. So my LHS will be 41 to the power of n minus 14 to the power of n, and my RHS will be 27k. Okay, 27 into k. This will be my RHS. So this is what my problem will look like. Okay, so we had done our check step. Check step is completed. So this is my first step. Okay, now in my second step, I have to assume that PM is true. Why? Because P1 is true. P1 is true, so I will assume that my PM is also true. Now let's assume that PM is true. Now what is the outcome of this assumption? What is the outcome? Outcome is an concrete statement. That concrete statement, how it will look like? It is 41 to the power of m minus 14 to the power of m is equal to 27k. Okay, 41 to the power of m minus 14 to the power of m is equal to 27k. Right? So this is the concrete statement which we had derived from our assumption step. I will write a step further that 41 to the power of m is equal to 27k plus 14 to the power of m. Okay, I will further drill down to this step. Next, let's move on to our main step, which is the induction step. So number 3rd, which is induction step, we will write our P m plus 1. Okay, so how my Pm plus 1 will look like? LHS of Pm plus 1. So my LHS will be 41 to the power m plus 1. I have to substitute m plus 1 in place of n. Okay, so 41 to the power of m plus 1 minus 14 to the power of m plus 1. Right? Okay, now in place of 41 to the power of m plus 1, we can write it as 41 into 41 to the power of m. Similarly, we can write here as 14 into 14 to the power of m. Now what is our third step? Third step, we have to sandwich second and third step. So how we will sandwich? We will use this 41 to the power of m in place of this 41 to the power of m. Okay, in place of this 41 to the power of m, we are using this 41 to the power of m. So let's take the value as 27k plus 14 to the power of m. So I will write it down here as 41 into 27k plus 14 to the power of m minus 14 into 14 to the power of m. Understood what I had done? From the concrete statement, I had taken what is the 41 to the power of m and I had substituted over there. This is what I had done for this problem. Okay. Now let's multiply this 41 to this bracket in this bracket. It will be 41 into 27k plus 41 into 14 to the power of m minus 14 into 14 to the power of m. Okay, got it? It will be 41 into 14 to the power of m minus 14 into 14 to the power of m. Now it will be 41 into 27k. In these two, you take 14 to the power of m common. So once you take 14 to the power of m common, let me write it here. 14 to the power of m is common. It will be 41 minus 14. 41 minus 14. Done. So this will be my 41 minus 14 into 14 to the power of m. What is 41 minus 14? It is 27. It will be 41 into 41 27k plus 27 into 14 to the power of m. Right? Now in this entire thing 27 is common, so you can take 27 as common. This is 41k plus 14 to the power of m. Okay, so this is 27 into bracket 41k plus 14 to the power of m. This entire thing in the bracket is a natural number. Definitely it is a natural number, right? So you can write it as 27 lambda. I will denote this entire term with lambda. So it will be 27 lambda. So what I can frame now? I can frame that Pm plus 1 is divisible by 27. Okay, my Pm plus 1 is divisible by 27 because once I divide by Pm plus 1, I will get answer as lambda, right? So my Pm plus 1 is divisible by 27, or it is a multiple of 27. So with this we can tell Pm plus 1 is true, hence the conclusion is Pn is true. So what is my conclusion? So this is what I anticipated in my RHS. So my RHS will be 27k. Okay, it may be k, it may be L, or it may be lambda, whatever it is. So it is in the form of 27k. So my conclusion will be Pn is true. Okay, my conclusion is Pn is true. Okay, so what we had done in this category of problem? In this category of problem, we had first done the initial basic check. Once the initial basic check is done, after that we had written a concrete statement. From concrete statement, you take one term out of the concrete statement and represent it in the other term, like 41 to the power of n minus 14 to the power of m is equal to, I had written as 27k. What I had done? I had written 41 to the power of m as 27k plus 14 to the power of m. Why I had written? Because in m plus 1 step, I will get a multiple of 41 to the power of m. So I will substitute this 41 to the power of m. This is what the logic behind writing this step. Okay, this is what the logic, that I will substitute my 41 to the power of m with this 27k plus 14 to the power of m. Okay, after that do your calculations and show that Pm plus 1 is true, and hence my Pn is true. Okay, right. Now we will move on to the category 6. Okay, I will rub out this. Now my problem is Pn 7 plus 77 plus 777 up to 777 repeated n digits. Okay, this is equal to 7 by 81 bracket 10 to the power of n plus 1 minus 9n minus 10. Okay, so this is the n digits type of problem. Okay, so here we had seen that first term is having 1 digit, 2 digits, 3 digits in 777, like that up to n digits it is having. So we have to prove that sum of this entire terms, which will be n terms, is equal to 7 by 81 into, that is bracket, 10 to the power of n plus 1 minus 9n minus 10. Okay, this is what my sum is. So what is my LHS? LHS is 7 plus 77 plus 777 till 777 of n digits. Okay, so this entire term is my LHS. Now what my RHS is? My RHS is 7 by 81 into 10 to the power of n plus 1 minus 9n minus 10. So this is my RHS. Okay, now let's do my P1, which is my check step. Okay, so in P1, let me change my marker. So for P1, what will be my LHS? My LHS will be 7, because it is one term. So one term is 7, right? So it will be 7. Now what will be my RHS? My RHS will be, I have to substitute 1 in place of the n. Here I have to substitute 1 in place of n. Okay, that will be my RHS. So it will be 7 by 81 10 to the power of 1 plus 1. I had substituted 1 in place of n. Okay, minus 9 into 1 minus 10. This will be my RHS. Let me solve this. 7 by 81 10 square minus 9 minus 10. This will be 7 by 81 into 100 minus 19, which will be 7 by 81 into 81. So this is equal to 7. Okay, so my LHS and RHS both are same. This shows that my check step is true. Okay, this shows that my check step is true. Now let's move on to my second step, which is assumption step. So I have to write a PM statement. For my PM statement, how my PM statement will look like? It will be 7 plus 77 plus 777 dash dash up to 777. How many digits? M digits. Okay, so how my LHS of PM statement will look like, which is the concrete statement? It is 7 plus 77 plus 777 till that M digits. Okay, for my PM statement there are N digits, so for PM there will be M digits. This is my LHS. Okay, now what will be my RHS? My RHS will be 7 by 81 10 to the power of m plus 1 minus 9m minus 10. Okay, so this entire LHS is equal to 7 by 81 into 10 to the power of m plus 1 minus 9m minus 10. Okay, so this is what the concrete statement we had derived in this problem. Let's move on to our main step, which is my induction step. So for my induction step, which is PM plus 1, how my LHS will look like? Okay, my LHS will be 7 plus 77 till that up to last 7777 up to m plus 1 digits. Okay, because it is PM plus 1. So let me write my LHS. My LHS will be 7 plus 77 like that. Okay, why I had written two terms over here? Because to show this is having m digits, okay, and this is having m plus 1 digits. Okay, this is having m digits and this is having, so it is alternate, like this is having 1 digit, it will be 2, 3, 4 like that. At last it will have m and it will have m plus 1 digits. This is how my LHS will look like. I told one of the best practice that we have to anticipate that how my RHS will look like. Okay, that is to keep us focused on the RHS. So how my RHS will look like? Let's write in our rough work that how my RHS will look like after solving. So it will be 7 by 81 10 to the power of, in place of n we have to substitute m plus 1. So it will be m plus 2 and after that minus 9 m plus 1 minus 10. Okay, this is how my RHS will look like. So we have to work to get this RHS. Okay, now in this sum, this entire thing we can substitute by this 7 by 81 10 to the power of m plus 1 minus 9m minus 10. Okay, because this is from our concrete statement and we have to use our PM statement. So I will write it as 7 by 81 10 to the power of m plus 1 minus 9m minus 10. Okay, till this m digits. Till this m digits we can write it. Now what we had left with, we are now left with this m plus 1 digit terms. So let's write that. This is with m plus 1 digits. Okay. What I will do, I will take my left hand side of the board and I will try to solve this, only m plus 1 digits. Now let's see what we will solve. Okay, so what we had written over there, 7, 7, 7 like that up to 7. This is m plus 1 digits. Let's take 7 common from this. So we can write it as 7 into 1, 1, 1, 1, 1, 1, 1 up to m digits. Sorry, m plus 1 digits. It is up to m plus 1 digits. We can write it like 7 into 1 is 7, 7 into 11 is 77, 7 into 111 is 700, 700, 777 like that. Okay, so we can write that 7, 7, 7, 7 up to m plus 1 terms is 7 into 1, 1, 1, 1 up to m plus 1 digits. Okay, so we can write it like this. Now we can, how we can write this in the form of sum? So 111 can be written as 100 plus 10 plus 1, right? So it will be 10 square plus 10 plus 10 to the power of 0. 1 can be written as 10 to the power of 0. So for 3 digits of 1, we are getting 10 square plus 10 plus 10 to the power of 0. Like that, for m digits of 1, what we will get? We will get 10 to the power of m plus 10 to the power of m minus 1 dash dash up to 10 to the power of 0. Are you getting this? Suppose I will give another example. Another example of 1111. 1111 can be written as 1000 plus 100 plus 10 plus 1. It will be 10 to the power of 3 plus 10 to the power of 2 plus 10 plus 10 to the power of 0. Okay, so how many digits of 1 are there? 4 digits. For 4 digits of 1, we are having 10 to the power of 3, starting from 10 to the power of 3 to 0. Okay, so like that, for m plus 1 digits of 1, we will have m to 0. Clear? Okay, let me rub this out. This is for just your understanding. Now just write it in reverse order. It will be 10 to the power of 0, 10 to the power of 1 plus 10 to the power of 2, like that up to 10 to the power of m. This is one of the series, geometric series. Okay, why? Because here ratio is 10. 10 to the power of 0 to 10 to the power of 1, ratio is 10. 10 to the power of 2 to 10 to the power of 1, ratio is 10. Like that, ratio is 10 for entire sequence. So sum, it will be a geometric series. Okay, so for a geometric series sum, it is given by sum of the geometric series is given by a r to the power of n minus 1 by r minus 1. Okay, this is what the sum is. Now, what is the geometric series? How we will get this sum? Go on to my geometric series class. Okay, sequence and series class will take you detailed explanation about what is geometric series. Okay, now let's focus here. Here A is the first term and R is the common difference. Here, common ratio, not a difference, it's a common ratio, it's a common ratio. Here common ratio is 10. Okay, here common ratio is 10. So how this will be? Here in n is number of terms. So here how many terms are there? There are m plus 1 terms because we are starting from 0. Okay, here we are starting from 0, 0, 1, 2 till that m. So it is m plus 1 terms. Okay. So my sum will be written as 7 into, what is my first term? My first term is 10 to the power of 0, which is nothing but 1. So A will be 1. What is next? R to the power of n minus 1. So ratio is 10. So it is 10 to the power of n minus 1 divided by, so my n will be m plus 1 here. So sorry, I will write it again. Here m plus 1 terms. So 7 into 1 into 10 to the power of m plus 1 minus 1 by 10 minus 1, which is r minus 1. So it will be 10 minus 1. So what will be my final conclusion? It is 10 minus 1, which will become 9. So it will be 7 by 9. And here we will have 10 to the power of m plus 1 minus 1. Okay, here we will have 7 by 9, 10 to the power of m plus 1 minus 1. Okay, so this entire 777 till m plus 1 digits can be replaced by this. So let's do the same here. So 7 by 81, 10 to the power of m plus 1 minus 9m minus 10 plus 7 by 9, 10 to the power of m plus 1 minus 1. Okay, so we had substituted this m plus 1 digits of 7777 by 7 by 9 to the power of into 10 to the power of m plus 1 minus 1. Okay, so this is what we had substituted. Now let me rub this out, this explanation. Okay. Okay. Now here, to make these two common, what I will do, I will multiply 9 and 9 numerator and denominator just to get 81 here and here. Okay, so I will multiply 9 and 9, multiply 9 here, multiply by 9 here. Okay, what I had done, just multiplied 9 with numerator and denominator to get same 81. So it will be 7 by 81, 10 to the power of m plus 1 minus 9m minus 10 plus 7 by 81 into, you multiply 9 inside, it will be 9 into 10 to the power of m plus 1 minus 9. This 9, okay, this 9 is multiplied inside, which will be 9 into 10 to the power of m plus 1 minus 9. Now you can take entire 7 by 81 common. So it will be 7 by 81. Okay, entirely 7 by 81 can be taken common. It will be 10 to the power of m plus 1 minus 9m minus 10 plus 9 into 10 to the power of m plus 1 minus 9. Okay, so what we had done, we had taken 7 by 81 entirely common. This is what our purpose, to multiply 9 and 9 in numerator and denominator, just to get 81 over here. So we had got the next step, that 7 by 81 10 to the power of m plus 1 minus 9m minus 10 plus 9 into 10 to the power m plus 1 minus 9. Now this 9 into 10 to the power of m plus 1 plus this 10 into m to the power of 10 to the power of m plus 1 will become 10 into 10 to the power of m plus 1. Okay, and this minus 9m and minus 9 will become minus 9m plus 1, and this will be minus 10. So how we will write it? So I will use my left hand side of the board. That's why I rubbed the entire explanation why I had written that 7 of m plus 1 digits is equal to that expression. Okay, I will use my this side of board. So here it will be 7 by 81. After that 10 to the power of m plus 1 plus 9 into 10 to the power of m plus 1. So this term and this term, both the terms I had taken out. Now I will take this term and this term, which will be minus 9m minus 9. Okay, I am combining all the like terms. This is minus 10. Write it as minus 10. Okay, so what my aim is? My aim is to get this expression, right? So it is 10m plus 2 minus 9m plus 1 minus 10. Okay, 10 to the power of m plus 2. It will be 7 by 81. 9 into 10 to the power of m plus 1, 10 into 10 to the power of m plus 1. So it will be 9 plus 1, which will be 10. So 10 into 10 to the power of m plus 1 it is. Okay, 9 into x plus x, 10x. Okay, what is the x? X is 10 to the power of m plus 1. So it is 10 into 10 to the power of m plus 1 minus. You can take 9 common from this. This is 9, and it will be m plus 1 inside. Okay, and after that you will be remaining with 10 minus 10. Done. Now 10 into 10 to the power of m plus 1. So both are same base, 10 10. So it will become m plus 2. So this will be 7 by 81 10 to the power of m plus 2 minus 9 into m plus 1 minus 10. Okay, so this is what we had anticipated earlier. These both are same, right? So Pm plus 1 is true. With this we will come into conclusion that Pn is also true. So what my conclusion is? My conclusion is Pn is true. Why Pn is true? Because my Pm plus 1 is true. Done? Okay. So what we had done in this problem? We had written a concrete statement. After the concrete statement, once we had moved to Pm plus 1, we had taken the m plus 1 digit term, which is a term which is having m plus 1 digits. By using a GP, we had formulated that term. That term we had replaced, and we had come up with the conclusion that Pm plus 1 is true, hence Pn will be true. Okay? Okay. Now we will move to our category 7. Okay. I will rub this out. my problem is 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial till that n into n factorial. This is equal to n plus 1 factorial minus 1. Okay, so this is the symbol of factorial. Okay, this is the symbol of factorial. So this is my problem. So what is my LHS? My LHS is 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial till n into n factorial. This is my LHS. What is my RHS here? RHS is n plus 1 factorial minus 1. So I have to prove this statement. Okay. Now let's understand first what is factorial. Suppose 3 factorial is written. That means 1 into 2 into 3. It is product of all the natural numbers lesser than the factorial number. Like lesser than 3, what are the natural numbers? 1, 2 and or lesser than or equal also. So 1, 2 and 3. So 3 factorial is 1 into 2 into 3. Okay. So this is what is the factorial. I think this is enough for you to solve this problem. If you want further detailed understanding, you go through the permutation and combination class. Okay. Chal. So what we will do? First we will check for our P1. First step, we will check for our P1. So what will be my LHS for P1? So my LHS will be 1 into 1 factorial because value of n is 1. So what is 1 factorial? It is 1. So 1 into 1 it will be 1. So my LHS is 1. Now what will be my RHS? My RHS will be, in place of n you substitute 1. So 1 plus 1 factorial minus 1. So this is 2 factorial minus 1, which is 2 into 1 minus 1, nothing but 1. Okay. So my LHS and RHS are same. So check is done. That means P1 is true. Now let's come to PM. PM is an assumption step and we will come up with a concrete statement. So how that concrete statement will look like? That concrete statement will be 1 into 1 factorial plus 2 into 2 factorial plus dash dash up m into m factorial. This is equal to m plus 1 factorial minus 1. Okay, this is equal to m plus 1 factorial minus 1. So what I had done, in place of n I had substituted m, and this is my concrete statement. Okay, let's solve for our main step, which is the induction step. So let's solve P m plus 1. Now in m plus 1, what will be my LHS? How my LHS will look like? So my LHS will be 1 into 1 factorial plus 2 into 2 factorial plus dash dash m into m factorial plus m plus 1 into m plus 1 factorial. Okay, so 1 into 1 factorial plus 2 into 2 factorial till m plus 1 term. Why I had written m? Because I have to substitute till m terms with this. That's why I had written till. That's why I had written m's term also. This is till m plus 1 terms. Okay. So I will substitute, as I told, I will substitute this entire m terms. Okay. So once I will substitute with this m plus 1 factorial minus 1, so it will become m plus 1 factorial minus 1. Now what we had left with? We had left with m plus 1th term. So m plus 1th term will be m plus 1 into m plus 1 factorial. Okay. Now in these two terms m plus 1 is alike. So I will take these two. I will combine these two. Okay. And let's take this minus 1 at end. So it will be m plus 1 factorial plus m plus 1 into m plus 1 factorial minus 1. Okay. So what is the like in these two is m plus 1 factorial. So let's take m plus 1 factorial. So this is the common in these two. Here you will be left with m1. Here you will be left with m plus 1. Okay. Now you subtract minus 1 from that. Okay. So this is the next step. Now m plus 1, it will be m plus 2, m plus 1, this will be m plus 2 minus 1. Okay. M plus 1, this is nothing but m plus 1 factorial, not m plus 1. So this is m plus 1 factorial into m plus 2 minus 1. Okay. Now let's use some our rough space. So 2 into 1 factorial, it will be 2 factorial. Okay. I will make it further clear. Like suppose 4 into 3 factorial, it will be 4 factorial. Because what is 4 factorial? 4 factorial will be 4 into 3 into 2 into 1. So this 3 into 2 into 1 is 3 factorial. So 4 into 3 factorial. You understood this, right? So 4 into 3 factorial is nothing but our 4 factorial. So like that we can conclude for any terms. 6 into 5 factorial. 6 into 5 factorial will be 6 factorial. Okay. So whichever is the term greater, there should be a difference between 1. Okay. Whenever there is a difference between 1 and m plus 1 into m factorial, that will become m plus 1 factorial. Like that, here there is a difference of 1. So m plus 2 into m plus 1 factorial. So m plus 2 is multiplied to m plus 1 factorial. So m plus 1 factorial will have m plus 1, m minus 1, m minus 2 till that 1 into m plus 2. So this entire term from m plus 2 to 1 will become m plus 2 factorial, right? So let me rub this explanation. Okay, this is just for your understanding. So this will become let me use my other marker. So this will be my m plus 2 factorial minus 1. Okay. So if you substitute in RHS m plus 1, then you will get m plus 2 factorial minus 1. Okay. Which we had come up with. So my Pm plus 1 is true. Right. So what is my conclusion? So my conclusion will be Pn is true. Okay, my conclusion is Pn is true. Okay, right. Now we will move on to our category 8. Okay, let me rub this out. So this is a category 8 problem. In category 8, n is involved in a trigonometric function. So sine is one of the trigonometric function. So what is my mathematical statement? My mathematical statement is sine x plus sine 3x plus dash dash up to sine 2n minus 1x is equal to sine square nx by sine x. So this will be my RHS. So RHS is sine square nx by sine x. What will be my LHS? My LHS is sine x plus sine 3x plus dash 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 up to sine 2n minus 1x. Okay, so that is my LHS. So my LHS I am saying that x is the multiple of odd terms. Okay, 2n minus 1 is also an odd term. Okay, so it will be equal to sine square nx by sine x. Okay, right. For this, let us start our P1. So this is our check step, which is P1. So P1, my LHS will be first term, because n value is 1, so it will be sine x. Okay, now what will be my RHS? RHS will be, you have to substitute n with 1, so it will be sine square 1x by sine x. This will be sine x. Okay, this will be sine x. Sine square x by sine x is sine x. Okay, so my LHS and RHS both are same, right? So my LHS and RHS both are same. That's why P1 is true. Now let's go to our assumption step, where we will write our concrete statement. Now in this concrete statement, we will write our m term. So how my LHS will look like? So for my PM, the concrete statement will look like sine x plus sine 3x dash dash up to sine 2m minus 1x. Okay, so this will be my LHS. This is equal to sine square mx by sine x. Okay, so this is sine x plus sine 3x plus dash dash up to sine 2m minus 1x is equal to sine square mx by sine x. So this is my concrete statement. I have to use this statement to prove my Pm plus 1. Now let's come to my induction step, which is Pm plus 1. So in this Pm plus 1 induction step, how my LHS will look like? My LHS will be sine x plus sine 3x plus dash dash plus sine 2n minus 1x, sorry, 2m minus 1x plus sine 2m plus 1x. Okay, sine 2m plus 1x. So this is my mth term, and this is my m plus 1th term. Okay, this is my mth term and this is my m plus 1. Why I had written mth term? Because I will substitute this entire m terms with my concrete statement. Okay, so that is what my intention to write this m terms. Now once you substitute m plus 1 in place of n, it will become 2 into m plus 1 minus 1, which will be 2m plus 2 minus 1, which is 2m plus 1 at the end. Okay, so you will get 2m plus 1 x. Now let us substitute this entire m terms from the concrete statement. So this entire m terms I am substituting from the concrete statements. So this is sin square mx by sin x. So let us substitute that. Mx by sin x. Okay, and what we are left with? We are left with sin 2m plus 1 x. Okay, this we had left with. Now what we have to do? We have to take LCM now. Okay, once we take LCM, it will be sin square mx plus sin 2m plus 1 x into sin x. Okay, entire thing divided by sin x. Okay, now before proceeding further in this problem, let's see how my RHS will look like. Okay, I told this is the best practice to write RHS, how it should look like. Okay, so my RHS should look like sin square m plus 1 x by sin x. Okay, I substituted n with m plus 1. So we have to focus to get this. Okay, we have to drill down to this. How we will do that? Now please go through my trigonometrical identities classes. Okay, trigonometric classes where I had shown the identities. Okay, so one identity is there, that is cos of a plus b minus cos of a minus b, okay, is equal to minus 2 sin a sin b. Okay, minus 2 sin a sin b. So this is what the entity is. So here we are seeing sin a sin b. That's why we will use this identity over here. So how to figure out? This is my a and this is my b. Okay, so a will be 2m plus 1 x, b will be x. With this we will come up with cos a plus b form. Okay, so how to come up with that? You see here, sin square mx plus, here it is minus 2. So let's remove minus here and make it plus here and minus here. What I had done, I had multiplied both sides with minus. Okay, here 2 is absent, so let's divide and multiply with 2. So make it as 1 by 2. Okay, make it as 1 by 2. Entire thing divided by sin x, which is my numerator. So what I had done, I had divided it with 2 because I am taking 2 sin a sin b here. Okay, that's why I had divided with 2 such that I can multiply with 2. Okay, now cos a minus b. So a is 2m plus 1x, b is x. Once you do the subtraction, it will become cos a minus b, because a minus b is with positive sign. A minus b is with positive sign. That's why it will become 2mx. Okay, a minus b, 2m plus 1x minus x. Now a plus b is with negative sign. So negative, a plus b will be, cos 2m plus 2x. Okay, so sin a sin b is drilled down to cos a minus b minus cos a plus b, half of cos a minus b minus cos a plus b. Okay, done. Okay, so this is one of the identity we had applied here. So further, if you will, let me rub out this section. I will make further use of it. Okay, now here cos 2mx is there. There is one more identity, that cos square theta, cos 2 theta will be cos square theta minus sin square theta. Okay, this is another identity, that 2 theta will become theta and theta. So here it is in the form of 2mx, and it is in the form of, if you take 2 common, then it is 2m plus 1x. Okay, so it is in the form of 2mx, it is in the form of 2m plus 1x. So both these terms, we will make in the form of cos 2 theta, which is cos square theta minus sin square theta. So let me rub this out entirely and write what identity I am using here. I am using here cos 2 theta is equal to cos square theta minus sin square theta. Okay, that is the identity which I am using here. So here it is cos 2 mx. So it will become sin square mx plus half cos 2 mx will be cos square mx minus sin square mx. Okay, and minus cos 2m plus 1x minus cos 2m plus 1x will, cos 2m plus 1x will become cos square m plus 1x minus sin square m plus 1x. Now this negative sign will multiply with that, so it will become minus cos square m plus 1x plus sin square m plus 1x. So I will do that multiplication of minus later. So let me write it out. Cos square m plus 1x minus sin square m plus 1x. Okay, so this is how it will look like. So now what we will do, we will take sin square mx plus half cos square mx minus half sin square mx minus, we will take it as plus half. Let's write this minus, let's multiply inside. So it will become sin square m plus 1x minus cos square m plus 1x. Okay, okay. Now this half of sin square mx, this is sin square mx. So these two, if you subtract, now this entire thing is divided by sin x. So let's have a denominator here which is sin x. Okay, so this sin square mx and this minus half sin square mx, this will become half sin square mx plus half cos square mx, right? Here it is cos square mx, and here you do arithmetic operation, sin square mx minus half of sin square mx. So you will get half of sin square mx plus half of sin square m plus 1 x minus cos square m plus 1 x. Now there is one basic identity from 10th class, okay, that sin square theta plus cos square theta is 1. So here we will use that. If you take 1 by 2 out, so it will become sin square mx plus cos square mx. So sin square mx plus cos square mx is 1. So this will become entirely 1 by 2. So this is divided by sin x. So let's not forget the denominator. So this will be 1 by 2. Okay, this entire term plus 1 by 2. This is sin square m plus 1x minus cos square m plus 1x whole divided by sin x. Okay, now just take half common from this, then it will be 1 minus cos square. Why I am writing cos term earlier? Because I want to make use that 1 minus cos square theta is equal to sin square theta. I want to make use of that identity. Cos square theta plus sin square theta is 1. So 1 minus cos square theta will be equal to sin square theta. I want to make use of that entity. That's why I am writing my cos square term up front plus sin square m plus 1x whole divided by sin x. Okay, so 1 minus cos square m plus 1x, it will become sin square x. Okay, sin square m plus 1x. What is the identity? 1 minus cos square theta is equal to sin square theta, right? Okay, so it will be half of sin square m plus 1x plus whole divided by sin x. Okay, so this is half of sin square m plus 1x plus sin square m plus 1x whole divided by sin x. Sin square m plus 1x plus sin square m plus 1x, it will become 2 sin square m plus 1x, and this 2 will get cancelled. So once 2 will get cancelled, you will get RHS as m plus 1x by sin x. Okay, so this is what we had anticipated. This is what we had anticipated, that our RHS will be sin square m plus 1x by sin x by taking this LHS. Okay, so what is my conclusion? My conclusion is Pn is true. This is my conclusion, right? This completes the category 8. This is the end of detailed explanation class 2. If you are happy with the content, please press like, share and subscribe. Thank you Stay connected.